Hello, I am Sumalata from Marlakshman Reddy Institute of Technology and Management, and I am currently pursuing third year in Computer Science and Engineering. And the present presentation is about IoT-based home automation solutions, and submitted in partial fulfillment of the requirements for the award of internship in IoT, which is submitted by A. Sanjana, K. Sumalata, T. Shravya, K. Manasa, submitted to Emertxe Information Technologies. And the task performed during course of internship is during the first week, C programming, and the second week, project requirements and design, third week, building the units, peripheral programming, and fourth week, this workshop. And topics covered in C programming, introduction to C and data types in car float double. Operators are arithmetic operators, bitwise operators, and logical operators. And conditional constructs are if, else, switch case. And loops are for while, do while. Arrays, strings, string functions, pointers, pass by reference and pass by value, functions and recursion. Memory segments are text, data, stack, and heap. Structs, introduction to C++ and OOPS. And project requirements and design Arduino programming. In this, we learn about the introduction parts, introduction to IoT, project IoT based home automation solutions, requirements and explanation, installation of PiximLab and Arduino IDE, introduction to embedded systems, introduction to Arduino IDE and overview of PiximLab, LED and programming, building the units, peripheral programming, and CLCD programming ADC, which is analog to digital converter, temperature sensor, and PWM module controlling LED using LDR. Project integration and testing. Blink app configuration, controlling heater, cooler, and reading temperature. Using blink and displaying notification on CLCD, configuration of serial tank. Requirements are controlling brightness of garden lights using LDR sensor and Blink IoT. Blink IoT is in mobile application. Controlling room temperature using temperature sensor, and it is about LM35 and Blink IoT. Measuring and controlling volume of water in water tank using serial tank Blink IoT. And later on, our teammate Sanjana will continue.
Hello, my name is Sanjana. I am from Marlakshman Reddy Institute of Technology and Management. I am pursuing third year in Computer Science and Engineering. I got this opportunity from internship of Emertxe, and it is about home automations. Garden lights control, LDR sensor, defined as light dependent resistor. It is a component that has variable resistance that changes with intensity of light that fall upon it. LDRs are often used in circuits where it is necessary to detect presence of level of light. We have a block diagram of it, Arduino Uno, LDR sensor and lights. The output of LDR is given to ADC, which is present in Arduino. When we have less light, we have more resistance and less voltage. When we have more light, we have less resistance and more voltage. Output of ADC. Output of ADC ranges from 0 to 1023. V out equal to 0 for less light, then brightness of garden light should be more. V out equal to 1023. For more light, then brightness of garden light should be less. Converting output voltage of ADC to brightness of LED. Brightness of output LED is more when the input value is high. Where ADC output or natural light is very less. Brightness of output LED is less when the input value is low. Where ADC output or natural light is very more. Output of ADC equal to V in to LED 0 to 255 and 1023 to 0. Home automation. Conversion formula. Input value equal to analog read or analog LDR, reading and storing LDR sensor values using ADC. Input value equal to input value by 4, changing range from 0 to 1023 to 0 to 255. Input value converting high equal to 255 input value. Converting high ADC values into low input voltage of LED and vice versa. How it works. When natural light is very low, we will get low output voltages from ADC, and using the conversion formula, we are providing more voltage to output LED. Suppose ADC output equal to 0, input value is 0 by 4, that is 0. Input value 255 to 0, 255. We get V in equal to 255. When the natural light is very more, we will get high output voltages from ADC, and by using the conversion formula, we are providing more voltage to output LED. Suppose ADC output equal to 1023, input value equal to 1023 by 4, 255. Input value equal to 255 minus 255, that is 0. We get V in equal to 0. By using these methods, we are controlling the brightness of garden lights according to the amount of presence of natural light. After doing this experiment, we get the output like this. This is the PiximLab spare parts. We get T is equal to 30.30. This is the program code. By executing this, we get that output. Now temperature control system will be continued by my teammate Mansi.
Hi, my name is Manasa. I am pursuing third year CSC in Mari Lakshman Reddy Institute of Technology and Management. Here the topic is temperature control system. The temperature control system consisting of a heating resistor and temperature sensor, that is LM35, and a cooler, which resembles the temperature control system at home. These temperatures is read from the temperature sensor LM35 and display it on the CLCD and control the temperature sensor of the system by turning on or off the heater and the cooler through the Blink IOT app. It is a block diagram of the temperature control system. LM35 temperature sensor. The LM35 series are precision integrated circuit temperature device with an output voltage. It is linearly proportional to the centigrade temperature. The LM35 sensor uses the basic principle of diode, whereas the temperature increases and the voltage across a diode increases at a known rate. The centigrade temperature is equal to the voltage read by ADC of 10 MV. Output voltage of ADC. The output reading from the LM35 sensor is provided by ADC. The output voltage converted into temperature by using the formula. Temperature is equal to analog read of A0 into float of 5 that divided by 1023 by float of 0.01. This analog read of is used to read the analog values and provide it as the input to ADC. Syntax. Analog read of pin. Pin is used to the number of analog input pin to read from sensors or channel values. For every 100 microseconds, it reads an analog input. Now it is based on the temperature value. It automatically makes cooler and heater on or off, respectively, and displays the state of cooler and heater in CLCD. If the temperature is greater than 35 degrees centigrade, then it automatically switch on the cooler and heater becomes off. Another way of control is by blink IOT. Blink IoT was designed for the Internet of Things, that is IoT. It can control hardware remotely. It can display sensor data. It can store data to visualize it, and many other cool things. Create widgets on mobile blink application. Button widgets to control heater, cooler, inlet value and outlet value. Gauge widgets to display the temperature and volume of the water in the tank of the mobile application. Terminal widgets to display the notifications whenever threshold is crossed, like temperature is more than 35 degrees, turning off the heater. When the heater is on, if the temperature rises above 35 degrees Celsius, then heater should turn off automatically, and the message is temperature is more than 35 degrees Celsius, turning off the heater should be displayed on the virtual terminal of as a notification in Blink mobile application. Heater off on CLCD. Arduino board does not have any direct communication through online or Wi-Fi. To make communication with an Arduino is possible by using external communication peripherals like Ethernet shield. It can be continued by Shravya.
Hello everyone, this is Shravya. Now serial tank. Serial tank inlet and outlet value control. Read the volume of the water in. Hello everyone, I am Shravya. Serial tank. Water tank inlet and outlet value control. Read the volume of the water in the tank through serial communication and display it on the CLCD control. Control the volume of the water in the tank by controlling the inlet and outlet value by sending commands through serial communication. Display the volume of the water in the tank on the CLCD and also have control. Now this is the block diagram of serial tank. This is the Blink IoT app. Through this, we can notify the volume in the tank, like what amount of water is present in the tank, so that we can switch off the motor. This Arduino UNO will notify the volume of the tank and also notifies volume of water to CLCD. The volume of water is decreases if the outlet value is turned on. Displays outlet value is on in CLCD. If the volume of water is below 2000 liters, the inlet value turns on automatically and sends a message, water level less than 2000 liters and inlet value is turned on. It will be displayed on the virtual terminal as the notification in Blink mobile application, and displays inlet value is on CLCD. When the water in the tank is full, turn off the inlet value automatically and displays water level is full. Water inflow is disabled. So to continue with the Blink mobile app, we need this code. This is the code for serial tank test. Through this, we can operate the level of tank. So this is the level of. So to proceed with Blink mobile app, we need one code. Like this is the serial tank test code. Through this, we can work with serial tank. Controlling serial tanks. All these three images are which displays the controlling serial tank information. Blink IoT configuration. Through Blink app, we can know the information like the tank is full or empty. Either it is full or empty, we can know by this app, and it will automatically turn it off and on. New skills required or learned. C programming, introduction to C++, introduction to IoT, project requirements and design, introduction to embedded systems, familiar with all the tools used in IoT and Arduino programmer, Blink app configuration, installation of PiximLab, Arduino IED, null modem, emulator, Arduino UNO overview LED module, LCD module, ACD module, PWM module and serial communication, controlling of devices using Blink app through Blink Cloud Server, IoT based home project. And the conclusion for this project is the internship at Emertxe Information Technologies helped us in learning various new skills. We have learned concepts like C, C++, IoT, and Arduino programming in this internship. This internship are worked on the IoT-based home automation solution project and simulator in PiximLab, and we used Arduino IDE to do the programming. It was a very good experience for us to work with Emertxe, which helped us to work in real-time problems using IoT. Thank you, IoT Emertxe, for giving this wonderful opportunity.